All right, in this video lesson, we are not going to write equations in slope-intercept form, but now we are going to use point-slope form. So again, point-slope form, you have y minus y1 equals m times x minus x1. Again, m is going to represent our slope, that is the rise and the run of our line. And we are going to use a point, and a point here, x1 and y1. So the two things we are going to be looking for here to write these equations are the slope and then a point. And our point can be any point that we want on that line. So think again of point, slope. The ingredients we need are the point and the slope. So let's start off first by giving you the ingredients straight off the bat. So again, I want to write the function y minus y1 equals m times x minus x1. Where I am plugging things in is I am plugging first into my slope, m, and then I'm going to take a point, and I'm going to plug in my x and y value for that specific point. Plugging in this first one, I have y minus my y value, which here is 3. So again, x and y for any point is going to equal my slope, 1/4, times x minus the x value, which is negative 8. Okay, now what I need to do is I'm going to simplify this. So I'm going to take this written in point-slope form and simplify this down. So the left side I can't really do much with right now. I got y minus 3, but the right side, first of all, x minus negative 8, we can change that right away to plus 8. Okay, minus and negative would be plus. But what I'm going to do is I'm going to take this 1/4. I'm going to get rid of the parentheses by distributing. So I got 1/4x plus, and if I did 1/4 of 8, a quarter of 8 would give me 2. Now I'm going to simplify this even further by isolating y of y minus 3. Let's take this minus 3 and add it to the other side. Because it's a number, I'm going to add it to the other number of 2. So it cancels out here, and I'm going to be left with y equals 1/4 x plus 5. And I want you to recognize that I took this information of the point and the slope, wrote it out here in point-slope form, but when I simplify that down, notice I get my equation written in slope-intercept form. My slope is still 1/4, but I've now identified my y-intercept here as 5. So that's kind of nice that when we write in point-slope form, that it simplifies down to something we're more familiar with. Same thing in this example. If I plug in my x and y and my slope into my function, I would have here y minus my y value here is negative 1. It's going to equal m, which is negative 2, times x minus 3. Now notice here the minus 1 is with the y, so I need to change that to a positive. Just like I did before, I'm going to distribute that negative 2 in this case, so I would have y plus 1 equals negative 2x, and then negative 2 and negative 3 would give me positive 6. Then to simplify further, I would just subtract 1 from both sides, and I would get y equals negative 2x plus 5. So again, started off in point-slope form and ended off in slope-intercept form. That is pretty freaking neat. All right, now let's go from a graph. So from a graph again, we can talk about slope-intercept form, but notice here I'm given 2 points, but neither one of these points represents my y-intercept. My y-intercept is where it would cross the y-axis, which this graph doesn't explicitly show. So I still need to write the equation of this line, but since I'm given 2 points and a graph, I can write this in point-slope form because I can easily find the point, or the slope, by going down and right. So knowing it's down 4, right 2, so my slope would be negative 4 is my rise, my run is 2, so negative 2 would be my slope. And then for point-slope form, all I got to do is choose a point. So I'm going to choose that first one. So my point here is 1, 2. So very similar to the last example we went through, if I plug this into my point-slope form, so y minus my y value, which is 2, equals m times x minus 1. And now I can simplify by distributing the negative 2, so negative 2x plus 2, because they're both negative. And then I got y minus 2 on the other side, and then I can finish this off by adding 2 to both sides to get negative 2x plus 4. So if I were to extend further, I would recognize that it would all the way up here, if the line extended, would intersect at 4. But again, I can identify the slope and pick a point given that graph. Now notice I picked this one 1, 2. I could have picked 3, negative 2, and I would have gotten the same thing as an end result. All right, now lastly, I have 1, 4, and 3, 10. It's actually a question that was brought up in the previous section. What if a point that I give you is not the y-intercept? So if that's the case, this is why we would use point-slope form. So here you're given 2 points, but the thing I'm missing is the slope. What the heck is the slope? Point-slope form, I need the slope. So, like we did in our previous section, we can find the slope by doing the rise and the run. The slope is going to be, for the rise, the change in the y values. So 10 minus 4 over the change in the x values, which is 3 minus 1. Simplifying, I'm going to get 6 divided by 2, which is 3. So if my slope is 3, all I got to do is pick a point. So I'm going to pick any random point. Heck, I'm going to choose the second one just for fun. So I'm going to plug that into my formula. So y minus my y value, which in this case would be 10, equals m, my slope, times x minus the x value, which is 3. Simplifying this, I'm going to start by distributing to get 3x minus 9, and then y minus 10. And then, just like before, I'm going to add the 10 to both sides to get y equals 3x. 10s would cancel, and I'm going to get plus 1. And there's my equation from those 2 points. All right, Lord have mercy on my soul. There's that function notation again. So again, function notation, we're replacing y with f of x. Same principle here is that the number that's inside the parentheses, that is my input, which always is my x values. And the number on the outside, that is my y value, which again is going to represent my output. So given here, when you have f of 4 equals negative 2, treat that as a point of 4 comma negative 2. So your x and your y. F of 8 equals 4. Your x is 8. Your y is 4. So notice I have my x1, y1, x2, y2. So this is like the previous example. You're given 2 points. So first thing I need to do is find my slope by doing my change in y. So 4 minus negative 2 and 8 minus 4. These are going to add together, give me 6 over 2, which is going to be 3 again. I'm sorry, not 6 over 2. Let me go back. That's going to be 6 over 4. Good catch, sir. Which is going to simplify down to 3 over 2. Now, using point-slope form again, I got to choose a point. So I'm just going to choose, let's say, the first one of 4, negative 2, just for fun. So in point-slope form, plugging that in, I would have y minus my y value, which is negative 2, equals my m, which is 3 over 2, times x minus the x value, which is 4. So this side, again, will simplify to plus 2. I got to distribute the 3 halves. Oh my God, I got to distribute a fraction. I'm going to have y plus 2 equals, I would have 3 halves x. Okay, 3 halves times x is 3 half x. And then 3 halves times 4 would be 6. And because it's a negative 4, I'm going to have negative 6. And then the last thing is just get rid of that 2. So I'm going to subtract 2 from both sides. And I'm going to get 3 halves x minus 8 as my end result. That's my function of my line written in slope-intercept form in the end. All right. Now, I want you guys to try this last example on your own. So you have g of 2 equals 3 and g of 6 equals 5. So again, 2 points written in function notation. What would you get for the equation of your line? All right, so I chose the 2 points again, 2, 3, 6, 5, wrote them in point form, found the slope by subtracting the y values 5 and 3 and the x values 6 and 2 to get my slope of 1/2. Using then the first point of 2, 3, plugging that into point slope form, I then simplified by distributing the 1/2, I know another fraction, and then added the 3 at the end to get 1/2 x plus 2 as my final answer. Lock it in. All right, last example here. We have ourselves a little modeling problem. Oh, my Lord. So here says student council is ordering customized foam hands. Yeah, to promote school spirit. You're number 1, sir. We're number 1. So the table here shows a cost of ordering different number of foam hands. And it wants to know, can it be modeled by a linear equation? And if possible, to write that equation. All right, so to write it as a linear equation, I got to recognize, first of all, does this table even represent a linear function? So looking at the numbers, I notice that my number of foam hands, notice it goes up by 2. That's good, but we got to look at the cost. So it goes from 34 to 46. That would be an addition of $12. 46 to 58. Ooh, it's another addition of $12. 78 or 58 to 70, another 12. Ooh, another 12. So can this be modeled as a linear function? You bet. Because all linear functions go up or down by a constant rate of change all the time. So what we're going to do is we're going to use this information to write that linear equation. How do I do that? Well, understand that each of these things right here, each of these pairs of foam hands and costs, that represents a point of x and y. Think of x as the number and y as the cost. So I think about this as, let's say, 2 points. I have here actually 5 points, so let's pick 2 of them. Let's say maybe I want to choose the first 2 points. So let's say that I have from this table, I have 434 and 646. Think of that as your x1 and y1, x2 and y2. I could have chosen any point, but I'm just going to choose the first 2 for funsies. All right. Now, what I got to do just like before is I got to first find my slope by subtracting the x's, which I know is going to give me 12, and subtracting, the y's, and subtracting the x's, which I know is going to give me 2. So 12 over 2 is going to be 6. So my slope is 6. Now what that 6 means is a 6 is going to tell me the cost for every foam hand. Right? $6 per, think of this as 6 over 1. $6 for every 1 foam hand. All right, now what I got to do is choose a point. So I'm going to choose this first point just because, heck, I could have chose a point for my table. But I'm going to use my point slope form. So y minus, I'll plug in 34 as my y value. My slope is 6, and then x minus 4. And then my goal would be to simplify. So here I would have 6x minus 24 is going to equal y minus 34. So then I would add 34 to simplify down, and I'm going to get y equals 6x, and a negative 24 plus 34 would be 10. Fantastic. Now this equation in general, we talked about the 6 means the cost for every foam hand. You have the plus 10, which means, okay, well, that's going to be my initial cost. So here's what you got to think about. The 10 represents the general cost. If I'm going to have this company make foam hands for me, there's a general operating cost for setting up, for materials, all that good stuff. But then every foam hand is going to cost me $6. So if I wanted 1 foam hand, you're thinking about $16, and so on and so on. So again, writing equations of lines, in this case using point slope form. Got any questions? Jot those things down. We'll see you guys next time.